So this lesson on basic concepts of probability, a few definitions here. We've got a probability experiment, what that is, an outcome, sample space, event. So I encourage you to read those carefully and kind of get comfortable with those. So as we use that language, you're familiar with it. Theoretical probability of an event is written this way, P of E. So the probability that E occurs is the number of ways that E can happen divided by the number of ways the sample space can occur. So important fact is that if you add up all theoretical probabilities, they should add up to 1, and we'll kind of talk about that. Here I've left some of these blank that I'll fill out now, and some of them I've already filled out, and I'll kind of talk through quickly. Leave answers as fractions unless you're indicated otherwise. That's important to know. Find the probability that you get a 5 on a fair die. What does Alex call it sometimes? A number cube. So a die is sometimes called a number cube. So a cube with numbers on it. So that's kind of a silly name, but whatever. What's the probability that a 5 is rolled? So if you've ever seen a die, it's numbers 1 through 6. There are 6 sides total. So the probability that a 5 is rolled, so probability that you roll a 5 is 1 out of 6, because there's 1 5 and 6 sides. Probability that an odd number is rolled, so probability of odd. We'd say probability of odd, well, the odd numbers are 1, 3, and 5 out of 6 possibilities, so there are 3 odd numbers out of 6 possibilities. So 3 6, which we would reduce to 1/2. Probability that a number less than 4 is rolled. By the way, I should do this. 1, 2, 3, 4, 5, 6. Those are your possible outcomes. So that's why I say 1, 3, and 5 are the only odd numbers. Probability that a number less than 4 is rolled. So P less than 4 is how we might write that. Probability that we roll something less than 4. So less than 4 would be from here up. So there's 3 numbers less than 4 and 6 possible outcomes. So again, so that's 3 6, which we would reduce to 1/2. Probability that a number less than 8 is rolled. P less than 8. Well, that's one of those I call so easy it's confusing. It's 6 out of 6, because there are 6 numbers less than 6 out of 6 possible outcomes, so that probability is 1. And what that means is that it is absolutely certain that you'll roll a number less than 6. Just another example you see often is cards. Cards and dice. Those are popular things to ask probability questions about. If you're dealt 1 card from a deck of a standard 52 card deck, find the probability of being dealt what? An ace. Well, looking at this handy table, there are 4 aces out of those 52 cards. So P ace, I would say, is 4 out of 52. And you do these enough, you'll learn what fractions reduce and what don't. But that does in fact reduce to 1 out of 13. Probability that a diamond, you get a diamond, so P diamond. Well, if you look, there are exactly 13 cards that are diamonds, so that's 13 out of 52, which that reduces to 1/4. Probability that you get the ace of diamonds. So now we're getting real specific. Ace of diamonds. I'll abbreviate that. So there's only 1 card, the ace of diamonds. So that's 1 out of 52. And so those are our probabilities there from cards. Other things that we'll do, and I've kind of written out some of these just to kind of move through these. 2 dice are rolled simultaneously, so 2 dice, and I didn't draw this. You can find all kinds of pictures of all the different outcomes with 2 dice, but there are 36 different outcomes there. So you could get 36 different possible outcomes for rolling 2 dice. So what's the probability of getting the number 5 rolled on both dice? So getting 2 5s. So probability of getting 2 5s. Just writing it that way. Well, if you look at that, it turns out there's only one way out of 36 to get 2 5s. I'm going to show you something real fast. There you go. There's the picture that's shown a lot. I'll just screen rip this and dump it in. There we go. Saves a little bit of time. So there you can see there's a 5, there's a 5. So 5 5. There's only one way out of 36 possibilities of getting 2 5s. The sum of your two numbers rolling turning out to be a 6, so there's the sample space for that, or the event for that. You can get a 1 and a 5, a 2 and a 4, a 3 and a 3, a 4 and a 2, or 5 and a 1. Notice those repeat, 4 and 2, 2 and 4, because those come up differently. There's a 1 5, there's a 5 1, a 4 2, a 2 4, and a 3 3. And it's kind of neat how you see they line up along that diagonal, by the way. And so there is that event. So that probability of getting numbers that add up to a 6 is 5 out of 36. There's 5 of those out of 36. What about 2 odd numbers? So probability of getting 2 odd numbers. So then you got to think about it and say, I'm going to highlight the ones where you see 2 odds. Highlight that yellow. 2 odds. So 1 1 and 3 1 and 5 1. And then no odds, or there's not 2 odds anywhere there. 1 3, 3 3, 5 3. So that's 2 odds. And then here, when they have the 4s, there's 1 odd. There's at least 1 even in every combination here. So none of those. 1 5, 3 5, 5 5, and so 1 2 3 4 5 6 7 8 9. So there are 9 out of 36 ways of getting 2 odds, and that one you need to reduce to 1 out of 4. So there's a good example there for dice. And just some important things, some important observations. I'm not going to read all those to you. I'll highlight a couple of them. Probability is never negative, so definitely keep that in mind. Probability is never greater than 1, so definitely keep that in mind. If something can't occur, its probability is 0. That all the probabilities for every outcome in sample space will add up to 1, so that's something that we use often, just in terms of reasoning. And this last one is something that comes up that if you know the probability of an event E, then the probability of its complement is 1 minus that probability. So in other words, probability of rolling a 2 is 1/6. If there are then 5 ways to not roll a 2, notice that probability is 5/6, and they add up to 1. So in other words, if you know the probability of an event, then the probability of its complement, so in other words, the probability that the event doesn't happen, is 1 minus the probability that it does happen. So that's a good observation and sometimes very useful. And I'll mention that again here in just a second. Experimental probability or theoretical probability, or empirical probability as opposed to theoretical. So empirical, think about this, empirical or experimental comes from data or a survey. Theoretical probability, just to compare those, theoretical probability is from, I'll say, general assumptions, from dice, from cards, from coins. So those are examples of theoretical probabilities. But empirical probability or experimental probability, you're getting your probabilities from like a survey or data or an experiment. That's why it's sometimes called experimental probability. So in that case, the probability that the event occurs is the frequency, observer, I should say observed, I'm just going to fix it on the video here, observed frequency of the event divided by the total number of times, total number of trials for whatever that event is, or whatever the sample space is. So in this case, we have 260 randomly selected people and asked about what's your favorite kind of music, and so here are their results. And so just some quick examples there. What's the probability that a person selected says their favorite music is jazz? And so if we're going to use this survey as a way of approximating those probabilities, then we would say probability that someone says they like jazz or favorite music is jazz is 31 out of 260. That's because there's 31 people say jazz, 260 total. Probability that they say rap or hip hop is 80 out of 260, which we reduced to 4/13. That it is not classical. So here's that complement idea, and so you're using that the complement idea. So in other words, that if you want the probability that it's not classical, if it was classical, you'd say it's 28 out of 260. So now it's essentially the complement of that. So it's 260 minus 28. So now it's 232 out of 260 as 0.89. Notice then the probability that it was classical, would be 0.11. So in other words, the complement of that, whatever's left. So in other words, if you had done this one first, you could answer this question by just directly subtracting this from 1. And so that's sort of what we did when we did that subtraction. So basically that it's everything else. If you put two of them together, you end up adding them up. So it's that it's classic rock or alternative indie rock. So you look at these two, and so you say, okay, 73 and 48 gave those two responses. So then the probability that it is one of those two, you say then it's 73 plus 48 over 260. So that's how you do those empirical or experimental probability questions.